Hi, good morning. Thanks for coming and joining me in my shop here. It's July 27th today. Another beautiful day outside, so I'm going to limit my efforts on the radio here. I'm going to focus on the mystery wire. This wire to nowhere I've looked at twice already along the way. Neither time did I sort out what this wire is. I really am very surprised, in fact. So we're going to take a close look at where it's connected. Look at the schematic again. Didn't seem to exist on the schematic. And see if we just can't figure out what the heck is going on with that wire. I don't want to continue. Whoops! I don't want to continue with the alignment work now until I sort that wire out. Assuming I can sort it out. Okay, let's get the bottom plate off here. There we go. Tip this up. Okay, the mystery wire. Here it is. Look, still a mystery. Okay, so I want to figure out where it is attached to this switch with absolute certainty, and I want to get a look in there to see what else. There's a ground connection that's very nearby, and first thing I want to do, because it's so easy, is just put the ohm meter on that wire. I can't remember if I found a ground on it last time or not. $60,000 ohms. Okay, to the chassis here. There's some insulation on the wire. Ooh, that could be why I got tests. Look at that, shorted. No, that's not shorted. That's shorted. Looks like a capacitor the way it's behaving. A leaky capacitor. I say leaky because if the meter is charging up a capacitor, it takes a fraction of a second, then you get the open circuit indicator there. Where's the charge going afterwards? It's internally leaked out. Well, that's what it looks like. It looks like it's hooked up to a capacitor. Oh, you know what we should do? Let me do a little better test here. This thing is hooked up to the band switch. What's that mean? Does that mean turning the band switch is going to affect this? Maybe I'm getting different readings at different times when I go to test it because without realizing it, I'm on a different band and getting a different behavior from this wire. So I'm going to use clip leads to hook up the ohm meter here. One right on the wire. And we'll just do these to the chassis here. That clarifies things right there. So So there's a ground on it now. Always grounded. You have to wonder where. If this is just hooked up to a grounded terminal, like, why would it ever be there? So I've done a couple other of these exact same radios, and I could dig up videos from those radios and go through them and try to spot this area. The weird thing is, the whole time in the back of my head, I've been hearing this. You've seen this before. You've seen this before. Have I? How could this possibly be a standard thing in the radio? Okay, let's look carefully at the switch here and sort out where this is going and what's going on in the back part of the switch. Okay, made myself a diagram here. Spent quite a bit of time studying the schematic, and I think I can tell the story to some degree. I think I know what kind of component this should be connected to. This should be connected somewhere. So let's just go over this and see if I haven't got this right. Now, look at my own diagram. Right, there's two sides of these wafers. There's a front and a rear, depending upon which way you're viewing it from. There's 1, 2, 3, 4 wafers. Wafer number 2 here is the switch that controls the panel lights, the dial lights. The rest are involved with the radio. Some have terminals on this side and terminals on that side. This one has terminals. This is the one we're interested in, terminals on both sides. So I've shown it here. These are the terminals you can see when you look from the rear. And these are the terminals that are on the front side. Okay, let's take a look at my diagram here. And so the wafer has two sides, of course, a front and a rear. We're looking at the rear. The front would be looking the other way. These two that I've drawn this way are on the front. The rest of these are on the rear of wafer. This is wafer number 3. Wafer number 3. Switch number 3, really. S3. This is the wire in question. It comes down, it ties to a terminal on the rear here. Same terminal runs over to a coil. I can show you this right here. This is the coil. And the wire that runs over to it is this wire right here, stopping at this terminal. According to the schematic, the other end of this coil is grounded. So I read this point with my meter set to a very high range. This may appear to be a short to ground. If I put it on a low range, and you actually measure 3 ohms here. So you're measuring through the coil. And this wire's going nowhere. Okay, so we're going to get on the schematic. We're going to find this point, and we're going to look at the situation here. Of course, it doesn't look like this on the schematic, which is always the challenge. Let's go there now. So here we are. Here's the wafer switches. Well, just to add in a little bit of challenge, one of the wafers is up here. This happens to be wafer number 2, and all it's doing is selecting the dial lamps. You can see it here. Selecting the dial lamps. And this, okay. So down here we have the wafers, starting at the front of the radio. This is the front side of the first wafer. Antenna switch S1. That's the back side. Skip number 2, it's up there in the other part of the schematic. This is number 3, front side. We're very interested in this. And this is the back side. Number 3, that's switch number 4. Coming back to here. I'm sorry, to here. I really meant here. I think part of my confusion last time I looked this over was front or rear. I got pretty turned around. And the fact is that the wire is connected on the rear. Now, you can't see my diagram, but I have in this position a ground indicated. This next position is the one with the wire that goes to the grounded coil. And this also has the extra wire. There's no extra wire here on the schematic. Well, I'll show you where the extra wire is in a moment. And the next wire is actually going up to the tuning capacitor. So come back here. We'll follow where the mystery wire is connected right here on pin number 8. We'll follow it up in the radio. Okay, follow it very carefully. It's this outside wire. It comes to here. So you see the wire connects to a coil that is grounded. And this is the one I'm reading 3 ohms through it. But there's the other wire. This is the other wire. This is the mystery wire. The mystery wire comes to what is now a mystery capacitor. C25, 8.2 on one radio, 4.7 on another. On the one I have, it's a 4.7 picofarad capacitor. Where is it? How did this happen? That's where I am with this investigation, right at that point. I haven't gone any further than that. We're now going to try to figure out what happened to the capacitor. This is almost certainly a mica capacitor, a little square box-shaped capacitor. I'm just staring at this, trying to extract anything I can pick up. So it goes to a ground. Now you might think this resistor is involved, but it's not, because it's just sharing this ground terminal on the schematic here. It doesn't have to look like this at all. So this capacitor, this one side could be going to ground. So we'd find a disconnected capacitor. There's no switch in here. It's just a wire straight to a capacitor, straight to ground. Or we can find evidence. Hey, maybe the capacitor shorted out and somebody cut it out of the radio and found out the radio worked without it. Maybe that's what's happened. So if that's the case, I'll never find it. Would I ever find evidence of its existence? And where would it exist? Right on the end of that wire, probably. Soldered to ground somewhere. Okay, let's go back. We're going to fish around very carefully within the range of this piece of wire and see if we can find a lonesome small capacitor. A lonesome small capacitor. Oh yeah, so I should finish my diagram here by saying this really, I'll draw it over here, supposedly comes to a capacitor which is solidly grounded. And this is a 4.7 picofarad capacitor. Okay, where are you, man? Well, right away I see this capacitor right here. Now it's probably in the circuit where it should be. It's probably not the missing one. So this wire that's up here, it may have been pulled up here. It may not be up here normally. It may be somewhere quite different. So we could find this lonesome capacitor. Oh my gosh. One side connected to ground. That's a big hint. Is there anything way hidden in there? Is this guy connected to ground somehow? Certainly is connected. Well, the next step would be to prove these capacitors I see. Well, they're connected to something. How could they be implicated? This we just bend it down onto there. We're done. Just looking for anything I can see that's a capacitor that's grounded. I don't see one. It's going to be inside this area. Well, you know what we could do is we could take a 4.7 picofarad capacitor and connect it. ground it, see what happens. Doesn't sound like the smartest idea. Well, if there's going to be if the capacitor ever existed, which I think it did, it must have one side soldered to a grounded terminal or right to the chassis. So where's that happening? So I can certainly see a chassis ground way down there. I don't see any capacitors in there though. I'm thinking if I look through the camera, maybe things will look different and I'll spot something that is just not showing up. Well, you know, my story's pretty good, except for one problem. Cut the capacitor out and the radio worked better. So left the capacitor out, didn't have one. Maybe it was Grandpa working with his own radio. Maybe that explains some of these pulled wires, which may not be pulled. This is maybe the way they're supposed to be. Sure doesn't look right to me, but in fact, this wire, this one here, looks like it should be under this wire and back running, like back along the chassis here, coming up to this position. How did this wire get on top of it? You know, this is coming right from the antenna here. And then there's, yeah, we know what this wire is. So could somebody have unsoldered this and fooled around? Then when they put it back, they just over the top, or is that really where it's supposed to go? We don't have a wiring diagram. Some radios have pictorial diagrams of what it looks like underneath. You could see this kind of stuff. Okay, I'm going to stop for a while. Let me see if I can find one of my old videos on this radio and see if I can't get this image in front of me and see that wire and see this whole thing. That'd be interesting. That'd be the first time I've ever done that. Okay. Okay, that's about the best I can do. In the lower right is a 981 that I purchased some time ago and sold, actually sold it. I don't sell many radios, and I sold this one. So we can look in there, and of course it has the original, mostly the original parts in it, whereas the one we're looking at here it's got replaced parts. But there's some very interesting comparisons. Like if you look at these parts here, you see exactly the same thing on the other image, which I really can't. I can point with my mouse. Can I do that? Yes, I can. So you can see it right here. Okay, so the area of interest is right in here. So unfortunately, it's got those words on it. Son of a gun. How do you like that? Let me move this forward a little bit here and just see what happens. Hey, who's that guy? What's he doing there? Okay, I'll move it forward this way. So just hoping to get a better image of the top area there. No, this is about the best we're going to get right now. Best I found so far. So too bad about the words up here. So on the radio in question, okay, the wire is sticking out right here. Let's just go up a little higher here. And there's certainly no wire sticking out here. So I've looked this over carefully. This capacitor is this one here, and see this guy here. That's this one here. There's one in here, and that's this one is this one, I believe. Well, they don't seem to be quite the same orientation, but they're pretty much in the same place. Get my cursor off there. I wish I could, if I could zoom this in. Can I zoom this in? Is that possible? Quality. I don't think I can zoom in. No. I can't do anything on my own computer. So there's that one there. We can see. There's a big one up here. It's very hard to see, and that's this one that's been replaced. There's nothing showing up because I'm looking in this area because the wire is sticking out here, but that wire could have gone quite a few other places. So you really need to look more askance here for capacitors that based on the theory. Based on the theory that I'm following. Just looking back and forth. So there's a capacitor. There's this one. Then there's a capacitor here. In the radio, it does not appear to be in the other one. Wait a minute, that's going backwards. It's not supposed to work that way. It's supposed to be a capacitor right through here. So here's a long shot. Occasionally these radios are built, and in the factory parts are put in which may or may not be necessary in the end. And in a similar way to how they twist this little wire up here. Oh, too bad we can't see that on the other radio. They could be cutting out parts that have been put in case their extra capacitance is needed. Is that the case here? I highly doubt it. I really do doubt it. I thought I did two of these. The other one was probably not a 981. It was probably a very similar radio. That's it. I'm kind of stuck here. Okay, here's another view of the same radio. I've worked on it. Wow, sorry, it just looks exactly like this one, doesn't it? You can see I'm replacing the same parts in it. Okay, now, can we possibly see a difference? Here, look at this. I can imitate my video there. We can look for something that is different on that image versus here. Oh, it's a little tough, isn't it? Because I wish I could zoom that thing in. There's a way of zooming, isn't there? What happens if I do this? It's zooming in everything but the image. Did it zoom in the image? I don't think so. Okay, I know another way of doing this. What am I? I'm hoping to see the wire itself. Really, the only hope is to have the close-up camera going in there. Because how am I ever going to see that there's a part in this radio that's not in this one? Which is what I'm theorizing. Wow. It has to be done with a camera has to look into this other radio. I don't know if I did that. Let's just quickly zoom through here and just see if I don't somehow flip on this is really slow. Closer up view. Actually, it's faster to do this one across the bottom. What's that guy talking about? Come on, get the close-up camera going. This could have been the period where I'd broken that camera. Didn't have it to use. Okay, we're not getting anywhere here. Okay, so I'm not getting too far with reviewing old videos, but I think I need a new approach. A new approach would be, yeah, drop something on the floor. That's my new approach. Check out, well, what is the supposed missing capacitor at the end of this wire doing anyway? Maybe if I study the schematic, I can kind of conclude what it is and what effect it has, and maybe the name of the game is to hook up the missing capacitor here and see what it does to the radio. That's so mysterious. Okay, let's see if we can figure out why this capacitor is even here. This is the supposed mystery wire and missing capacitor. Supposed. Well, let's take a look at this. So this is the broadcast RF coil. Now the interesting thing about that for me is if this capacitor is having an influence on something, it has to be the broadcast reception band, which appears to be working fine. So it appears. And I mean, the objective of this is the antenna signal is amplified by this tube and then comes down through this coil. If it's, well, comes down through this coil no matter what, AM, or no matter what band you have on. If you do have on a shortwave band, then this is what picks up the signal and carries it on. But if you have it switched to broadcast, like magic, it's this one down here that is operating. This one, why do you need this capacitor grounding the top of the coil when you've got the bottom grounded? You can't put a ground on both ends. That would nullify this. So this has to be a frequency sensitive partial ground, if you like, a filter of some sort. And the size here has probably been picked very carefully. You see, it's different from the two radios. So what is it that they would want to disappear into the chassis rather than pass through this coil? That's not quite the right way to say it. What could be going on here that this capacitor would help with? Well, first of all, there could be some kind of resonance thing going on, and there could be a tendency to oscillate, possibly. And this capacitor may remove that tendency to oscillate. That could be one possibility. Another one is they just want to drain away all the higher frequency signals, which are of no use. You're really after the broadcast band. It's fairly low frequency, up to 1600 kilohertz. Everything beyond that is a waste. Why not kill it through this capacitor so it doesn't get in here and do something? I don't know what it would do exactly, but waste the energy of the radio in some way. So that would be a possibility. So what if it's not there? Oh, okay, let's ask this question first. What if it's there and it's leaky? Or worse yet, what if it's there and it's really defective? It's got a short in it. Well, clearly, if it's a short in it, you wouldn't have a broadcast band working anymore. If this was open in the sense that there's no capacitance here, even though the capacitor is sitting there, then we would have the state we have right now. But you know what? That wire that we have along the side of the radio, that wire could be 4.7 picofarads. The wire could be in the capacitor again. Doesn't seem likely to me. Seems a little loosey-goosey to have done that. And I didn't see it on the other radio. Or did somebody cut away the useless length of wire in the other radio, like me? What's this piece of wire here for? And cut it away. Don't think I did that. I don't think this wire is apparent. Could it be in some models this capacitor appears? Some 981Xs, this appears, but in later versions they just did away with it because it wasn't doing anything anyway. So I have a later radio I worked on earlier, and this whole capacitor thing is gone. I doubt that. Well, the next thing to do really is to hook this wire up to a capacitor to the chassis and see what goes on. I can set it up so I can kind of click it in and out of the circuit, and then we'll see what effect it has on the radio. I think we got to try that. Okay, we will try that. You know, there's a lot of things about this that just are not adding up at all. So 4.7 picofarad sounds like 5 to me. This is a 5 picofarad capacitor. First thing that came across my mind when I grabbed this is if I were going to, if I were engineering and designing this radio, not that I'm capable of doing that kind of thing, where would I put this capacitor? Well, I wouldn't put it at the end of a wire that ties to a terminal and then at the end of another wire out here. Why would I do that when I can connect it right to the terminal in question and put it to ground? Why? There is no reason for having this wire. Unless, again, the wire is the capacitor. There's no way I can measure the capacitance of this, but I can move it around and see what effect it has on the radio, but I can't imagine it has any effect that's perceptible. Okay, so we got a couple options here. Tune the radio to a broadcast station. Fiddle with this wire, just moving it around, seeing what happens. So I'm moving it farther and closer from this plate. This plate is grounded, and so this in effect is greater capacitance, less capacitance. See what that does? I have a 5 picofarad. I can kind of stick it on here, and I can find a place to ground it even temporarily. See what that does. Wow, it's really kind of like a shot in the dark, but I don't know what else to try here. Okay, we'll get the radio operating, and then we'll do it. Okay, while the radio is warming up, I got that horrible squeal out of it suddenly, and I think it's from a volume control that's dirty. It's not doing it now. Sounds good now, actually. Quite a low rumbling. I don't know if that comes over the video or not. I'm shaking my bench. I can spray into this one without turning the radio over. Didn't I do these already? Rumble by cutting the bass back a bit. Not that it matters. Okay, fiddling around off on my own. Okay, we got to tune in the French station. Now, I'm going to move this wire around. Are we going to be able to tell anything? You know what? The AVC meter is critical in this. Wish I could speak French. Like lots of English Canadians, I took French from grade 6 all the way to grade 11. And I couldn't put a sentence together at this point. Terrible. That's not so much me, it's the way it was taught. Okay, what am I doing? I want to read the. What am I doing? I'm drifting off into my public school days here. So we're going to hook this meter up. Again, a good place in most radios to pick up the DC AVC voltage oddly enough, is right on the volume control, the input side of the volume control. Okay, I see a little voltage here. Is it real? Yep. So this tells us the strength of the signal the radio is receiving. This is interesting. That's the French station there, and this is a noise signal just near it. Look at that. I wonder why you have a hard time picking stuff up with a radio. Here comes that crazy clicking thing. Came and went. Okay, we're ready now. Let's put this upscale a little further. Now I'm going to move this wire around and see what happens. Watch this meter really carefully. Oh, it does affect it. Better, worse, better. That's interesting. No, I didn't set this up for... I'm going to try to just put this on. And the motorboat's running. Oh my gosh, look at that! Ho, 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 ho. Okay. Wow. Very good. So why not mount it right up here? Why not have it up here? Be like this. This is the same thing. So where's a local grounded terminal? Up in here. So I have to cut this wire away, put this capacitor in here. Okay, we don't need to listen to that. So I need to find a grounded terminal. Just looking around. Bet you this is a ground here. Got everything hooked up to it. Maybe not. So I'm looking for a wire that actually goes down to the chassis. No, I don't think so. Is there anything grounded up and around here? So I got to find something within range, and that might be the answer for why this wire is here. There's just nothing within range that you can reach with a single component. Wow, I'm really quite impressed here with the effect of this. I wonder if that's the right size. What happens if you change the size? And that's going to be throwing off the alignment? Probably not. Probably not at all. Okay, I need options for a ground terminal. There's one right there. You could use that. Right there. Come on the end of the wire and go down to here. I'm not sure about going all the way up. And hey, is it better if you use the end of the wire? Yeah, look at that. It's just increasing the capacitance a little bit. Okay. So we go here. Hold still. It's up around the 14 number there on my dial. There we are. Okay, so it's 5 volt scale, 4.4 volts. And now if we do it here, I can't imagine this will be any different. I guess I can use this as a ground. Not a very good one. Let's try it this way. Less. We get less. How much less? So a little bit less. Doesn't really matter how much. Let's try that again. So here, hook it up here. We get 3.9. Hook it up here. We get a much higher. Well, not much higher. A little bit higher. Why would that be? Because there's some additional capacitance in this wire. I need to find a grounding terminal. A grounded terminal there. Oh my gosh, it turns out there's a grounded terminal right next to the end of the wire there. So this could be fit in quite easily right in here. Let's just try it. See what happens. There we are. Because I could push the wire down, fit this down inside, but how awkward is that? Push the wire down, make it. I don't want it so close to the bottom plate, but put the bottom plate on, the stuff's going to short out. There's no spare terminals. Actually, there's a lovely ground point right there. Is there something cut off right here? Watch it, man, the radio's on. Stick your fingers in it. Well, I think I can fit this guy right in. Ooh, 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 ooh. Did you hear that chirp when I turned it off? Chirp. Okay. That's what I'll do. I'm going to fit that in there. I think we're done with this issue. Okay, before I permanently put in this capacitor, I think some experimenting might pay off a little bit. I have some alternate size capacitors here. Let's turn this down. So, starting with the 5, just to verify what happens on the meter here. Starting with the 5 and grounding it just right here. Okay, so the reading is 4 volts exactly. 4 volts. Now what happens if we take a very different size? This is at 1/5 the size of the last capacitor. It's almost nothing. It still has a beneficial effect. That was a 1. Let's see if we can find a 3 here. This is a 4. I think that's a little higher. You know what's happening? It's how I bend the wire. It's how I move this wire. So we're talking 1 picofarad's making a big difference. 12. Okay, we'll go way up here. We'll jump up from 6 to 12. What happens if we do a 12? I think this is how they design radios. So we don't get up anywhere near as high. 12 way too big. Can we find a 10 in here, or maybe an 8? 1, 3, 5, and 10. So unfortunately, I don't have a good range here to experiment with. That's a 2. No, we're not getting up there. 5 looks pretty good. 4 or 5. So we're supposed to be 4.7. I got a 4 and a 5. 4.7's in between. Okay, 4 or 5. Which one's it going to be? So we're well over 4 volts there. This one, we are well over 4 volts there too. Okay, we're splitting hairs apparently. Something's better than nothing. A wire pushed up against the side is a good idea. Okay, I'm gonna install this, and we're gonna call the mystery solved. Let me install it here. Okay, got him installed there. Got this wire pushed up nice against the plate. Good, that's good. And I'm pretty sure this is clear. Let me just double check that. No, it's not. Put it in like that. Okay, now it's clear. And not shorted anywhere. Good show. Okay, let's turn on the radio and see if we get that magic 4 volts again. Volume down, power on. Let's do it like that. Okay, where are we? Oh my gosh, it's 11:30 in the morning. My whole morning is gone. Although I have been watching TV on and off. Lex Fridman interviews, which I enjoy very much. And I'm watching somebody's explanation of electrical discharges, which is actually quite interesting too. Hello, radio. Well, we didn't get 4 on the meter. We didn't get 4. How come we didn't get 4? Grab the end of that. Okay, we're gonna... I'm going to cause a short circuit here. Looks like bending the wire out will help. Okay, bend the wire out. Give me a stick. We don't need to listen. Okay. I'm going to push this wire out, watching the meter. Now, the farther I can get this wire up against the deck here, the better it is. Pushing it back here. It's begging for more capacitance now. Why are you doing that? Here's a 1. Okay, we're going to add a 1. 1 with a fair bit of wire here. Oh, just adding my finger. Just. Phew. So this meter is indicating the strength of the signal coming through the radio. When it goes up, the radio is doing better. It's receiving more. What are you supposed to do with that? I'm only hooking up one side of the capacitor. I'm sticking my finger on it. No, my finger doesn't help. Okay, if we add it in, I can do it. Get ready for a big... No, there's really no voltages here, I don't think. Oh my god, I just hook it up and leave it hanging open. That's what the wire was. That just sounds crazy. Clip lead. Let's just keep doing crazy stuff. What if I clip a clip lead on there? Wave it all around. So this is what you have to do. You have to have this wire hanging out of this radio, and you gotta whip it all over the place. Pretty close to 4. Let's go tuning this radio now. Now I did all this on just one frequency on one band. Okay, it's picking something up in the middle of nowhere. Very good. Whoa. It's a whopper of a noise. Is that 680? 680 or 640?
Perfect scheme to what is a good trade deadline.
So that's 590.
Trade deadline for Rothbach. Hold on, I'm looking up a guy's.
This must be 710 from St. Catharines. That's fantastic. No, it can't be 710. This has to be, this must be 680. I think 680 is right under that. .710 would come here. Oh! Okay, fact is, even if this isn't done exactly right, the radio is working really well. So, definitely quit while you're ahead type situation here. Well, that ends the mystery. I declare the mystery solved. And now we'll carry on with the alignment. I don't think this had any effect on the alignment of the radio so far, doing this. Good. I think. Very good. Very happy. Okay, well, thanks a lot for watching, and I got to get out of here because the day is gone by. See ya.